Okay, so we're going to be going over the Unit 8 practice test. Really quickly before that, I just want to show one thing. So I'm going to go ahead and share my screen really quickly. So if you look here, just a reminder that you can always find the office hours schedule here for any of the teachers, and you're welcome to join any teacher's office hour or request office hours on there. And then just a little reminder on how to submit photos of your work using your computer or using the Canvas app. So those are two good places to look. And then what we're going over today is the Unit 8 practice test. So everything from this week, this is kind of like really essential items. Unit 8 practice test, if you wanted to print it, is here. Solutions are here. Since there already is a video that explains how to do some of the problems in this video today, I'm not going to be going over all of them, but you can always go back and look at this video here to see the ones that we're not going over. Okay, and we will go ahead and get started. Let me share this with you. Okay, so the first question, since I did this one in the video, and I'm going to go ahead and do these three here. So with this question here, we were solving for n by using the zero product property and or factoring. So if you notice this question too, it's already in factored form. So then I could just take n minus 1, set that equal to 0, and I could also take n minus 4 and set that equal to 0. So then I'm just solving for n in both of these cases. So if I add 1 to both sides, n is 1. If I add 4 to both sides, n is 4. So our two solutions would be 1 and 4, so that would be here. We're going to do the same exact thing for question number 3. We can take m plus 5 and set it equal to 0. So we subtract 5 on both sides, n is negative 5. And then we can take our other factor, m plus 4, and set it equal to 0. And then we can subtract 4 on both sides, and we would get a negative 4. Okay, so if you're writing this on your piece of paper or on the practice test, do make sure that you're writing down your work, so you do need to submit it on Canvas. Just a little reminder there. And then for this last one, 3p plus 5, we're going to set that equal to 0. So there's actually a couple steps for this one. So we can subtract 5 on both sides. So 3p equals negative 5, divide by 3 on both sides. So we would get negative 5/3 as one of our solutions. And then we take our other factor, 5p minus 2, set that equal to 0. We can add 2 to both sides, 5p equals 2, and then divide by 5 on both sides. So p is 2/5. So we have negative 5/3 and 2/5. So it would be this solution here. Okay. Now questions 5, 6, 7, and 8, they all need to be put into this factored form first. So it looks like on my practice test, I did number 5 in the video already. So I'm not going to re-go over that one. So if you need help with 5, you can rewatch the video. And then I will go over 6, 7, and 8. Let me just grab a piece of paper, and it might be helpful if you're printed this out to put it on a different piece of paper, because there's not a lot of space on here. All right, so question number 6. We've got p squared minus 9p plus 18 equals 0. So remember, this is the box and diamond method. So we could create our box and our diamond, and we put the first term in the first box and our last term in the last box. We multiply them, and that goes to the top of the diamond. And then our middle term goes to the bottom of the diamond. So we're looking for numbers that multiply to 18, but add to a negative 9. So I know I need to have I need to have 2 negatives. Let's see. Because the only way to multiply to a negative is for them both to be multiply to a positive is for them both to be negative. So then I would just start thinking of what numbers multiply to 18. Well, 1 and 18, 2 and 9, and 3 and 6. So these are the only options of things that multiply to make 18. And then which of these two add to make negative 9? well, I could do these two here. So 3p and 6p. So then I could put these in either order. So negative 3p and negative 6p. And then we have here the common factor between p squared and negative 6p would be a p. And then our common factor here would also be p. And then to create the outside dimensions of the diamond, I would say, okay, p, if I multiply it with negative 6, that gives me negative 6p, and p, if I multiply that with negative 3, gives me negative 3p. And so now, if I want to go from this format here to what we call factored form, I would get p minus 3 as one factor and p minus 6 as the other factor. And then I would just set those equal to 0. So p minus 3 equals 0, p minus 6 equals 0, and then I would get 3 and 6 for my solutions there. So that's question number 6. That would be 3 and 6. So we've got that here. Let's see. I don't know if I went over I didn't go over question 7 or 8 in the other video that I made. So I'll go over question 7 and 8. For this one here, before you actually do the box and diamond method, we need to get everything on the left side and it needs to be equal to 0. So the first thing I would do then for this problem is I would add 8n to both sides. So we have 35n squared. I'm going to add 8n, so it would be plus 8n. And then I'm going to take this 16 and I'm going to add it to the other side as well. So it'd be minus 16 equals 0. Is this the same test that you have, your practice test? Are the questions the same? This question looks different than one of the ones I had. Okay, just checking. Okay, so now what we would do, first step, we put first term in the first box. And we put the last term in the last box. We multiply these two, that goes to the top of the diamond. So we're gonna have kind of a large number here. Hold on. So 560 n squared, and then the middle term is 8n, so that goes to the bottom. And sorry, this is negative. So we need one positive and we need one negative. So let's see, 560. So I'm looking for factors of 560 right now. Sorry, this is taking me a little longer than I thought. Okay, so got it. It's 20 and 28. So I don't think we did numbers that are quite that large on the test. So 20 multiplied with 28 gives us 560. So we would want to make the 28 positive and the 20 negative. So those two will go here. And then we'll put our common factor between these two at the top of the diamond. So it looks like 5 will go into both of those. So I put 5n here. And then what goes into both of these would be a 7. So I can put a 7n here. So then 5 multiplied with a negative 4 gives me negative 20. And 7 multiplied with a positive 4 gives me 28. And then these two multiply to get that last box here. Okay, so then we get 5n plus 4 is one factor, and 7n minus 4 is our other factor. And then from this problem, all you would have to do is do 5n plus 4 equals 0. Okay, so subtract 4 and divide by 5 on both sides, and then 7n minus 4 equals 0. You can add 4 and then divide by 7 on both sides. Okay, and the last question for factoring, this one here, I'll go ahead and do it on the paper since I have a little bit more space. If we add 4 to both sides, because remember we need this side here to be 0, I would rewrite this problem. Look like that. And then we can do our first term in the first box. That's 3n squared last term in the last box, multiply them, that goes to the top. So it'd be 24n squared, and then the middle term goes to the bottom. So then we're looking for numbers that multiply to 24, that add to negative 14. So they would both need to be negatives. So you could do like 1 and 24, 2 and 12. So 2 and 12 would work. Okay, so common factor between these two, this would be a 3. And then common factor between these two, well, they don't have any number common factors, so I just put an n here. And then n times a negative 2 would give me negative 2n, and 3n times a negative 4. And then you would just create your two factors for this problem. So 3n minus 2 equals 0, and n minus 4 equals 0, and then just set both of those equal to 0. Okay, so that's factoring and using the zero product property. And then our next one, so we have 9, quadratic formula. So it looks like I did this one in the video. So I'm not going to go over question 9. Let's do question 10 though, for sure. So, sorry, let me grab a piece of paper just because I'm running out of space. So for this one, we're using the quadratic formula. So we have our A value is 4. Our B value, it says negative n, so there's no number there. So we just say negative 1. And then our C is negative 11. So remember our quadratic formula, negative b plus or minus square root b squared minus 4ac all over 2a. So then we just plug our numbers into that. So negative, we put the b here. So I'm just going to write this out. All over 2a. So anytime I see like a variable, I'm going to put parentheses, and then inside that parentheses, I'll put that whatever that is represented with. So b is negative 1, a is 4, and c is negative 11. So typically what I'll do on my calculator is I'll do x equals, so this is negative times a negative, so it should be 1 plus or minus. And then everything that's underneath the radical, I'll usually put in parentheses and rewrite it out. So negative 1 squared minus 4 times 4 times, what is that? Negative 11. So it'd be 177. So everything underneath here simplifies to 177, and that's all over 8. Now I just need to figure out, well, what is the square root of 177? So calculator again, and I want it in decimal format. So remember, you push this little button on your calculator. It's about 13.3. So my answer here is going to be x equals 1 plus or minus 13.3 over 8. So we get two different answers. One answer when you do 1 plus 13.3 over 8, and then one of your answers is going to be 1 minus 13.3 over 8. So on our calculator, 1 plus 13.3 divided by 8 will be 1.7875, and then 1 minus 13.3 divided by 8, and that'll be negative 1.5375. So then I would just look and see what does that match up with here. And that would be this one for C. And then if I'm looking at question 11 and question 12, I actually did go over those in the video. So I'm not going to go over them again, but we'll start here on question. But you're just using quadratic formula for both of these again. Okay, and then question 13, let's see.